So for those who just joined us, this is the Data Solution Class Interactive. My name is Santiago, and this class is all about doing that, putting data in a more understandable format. That includes not just visual representations, but any extra stuff that would go into it, like audio, force feedback, VR, interactive experiences. Have you guys seen the work by Dan Goods? So Dan Goods actually, I think, graduated from Art Center, and he has an art-based courses right now at the Huntington Garden, which is a dome where you go inside. You can actually hear pings from every satellite and man-made thing that's around Earth. So it's actually an experience, and it's an art experience, but it is actually showing you some data. And that's what at the core of data visualization. And in fact, what is really important to us, and what we try to drive here, is finding the truth in the data, right? Or at least conveying the truth. So most people think that to make a powerful data visualization, it needs to look like something. You need to say, okay, I see this data, and all of a sudden there's these 5 things here. I can pick them out, and this is a wonderful investment, or this is the right time to be driving from here to here. Sometimes the truth can be boring. Sometimes the truth can be, you know what? Traffic is empty right now. There's nothing happening on the highways. But right now, you know what? You can invest in any of these markets, you're going to make just as much money. It makes no difference. It's just about conveying the truth. If you hide it, if you overhide it, then we're in trouble. Then if you can overrepresent it, you can exaggerate, that's when we start to get into trouble. Okay? And in fact, we're going to have a lecture later on in the term about actually artistic representations and actually doing exploratory experiences and museum pieces and all this stuff, sensory stuff. And that's really interesting, but again, we're always going to have to drive back to what is data visualization and representing the truth. So that's something that we're going to just kind of harp on over and over and over through this class. So how did this all start? I love this example. It's actually the drawings of Galileo. So he stood about 400 years ago in 1612, and he was trying to figure out how fast is the sun rotating, right? So so what he did is he just sat there, and I'm sure he put some goggles or something to cover up so it's not that bright, and then he actually drew the spots on the sun. He drew one page, and then he came back a week later and he drew another page, and he kept on drawing and drawing and drawing and drawing. And just by eventually seeing the pattern of the sunspots coming around, he said, oh, I can see the direction the sun is rotating, and he could actually tell how many days it took to actually for the sun to rotate. So was there any other way he could have done this? I mean, he had no instruments, so it had to be visual, and he had to come up with a representation. He couldn't have, to kind of try to figure out, okay, this spot looks like a little kid grabbing 4 balloons. So the kid with 4 balloons is at this position on the sphere, and then the kid with balloons is this position on the sphere. He would have to write something extremely complex just to be able to kind of figure out when the thing happened. But visually, I've never tracked a kid with balloons. You see me there? Yeah, you can see the movie there. But just visually having a little notebook and be able to actually kind of look at it was able to actually give him the answer and really understand the complex data. And visualization made it really simple. So then he went online, he made a first GIF, and he posted it to Facebook 100 years ago. So now that versus more modern stuff. So I mentioned that we do the summer project with Maggie and Scott David from JPL and Larry Mashkin from Caltech. And one of the projects that we did was a visualization of data from the LIGO interferometer. Have you guys ever heard of the LIGO interferometer? So the LIGO interferometer is this massive instrument. There's actually 3 of them in the world. where they have two mirrors about, I think, 3 kilometers apart from each other. And then they shoot a laser between these mirrors. So the laser the light goes to one mirror, it bounces, and it goes right back. And it just keeps on bouncing back and forth, back and forth, back and forth. So you figure if the mirrors are perfectly calibrated, the laser will just keep on bouncing back and forth perfectly, nothing would happen. But what they're trying to do is they're trying to detect gravitational waves. They try to, the force of some exploding black hole somewhere else, creating gravitational ripples and going through our Earth. And what would happen is if you have a light that should bounce perfectly back and forth, if one of those gravitational waves ever came through here, then the light all of a sudden would get distorted, and all of a sudden it would not bounce exactly in the same spot, but it would bounce a little off center. So this is basically an instrument to detect gravitational forces. So they created. There's one on the East Coast. They're building one in India, and there's one in Europe as well. And it turns out that this thing is actually extremely good at detecting earthquakes. The interferometer here in the U.S. can easily detect earthquakes in China because the movement of the Earth actually distorts this thing faster than the actual wave of the earthquake. So this thing is also good at detecting, garbage trucks just driving around the neighborhood, because the whole thing just vibrates a heck of a lot. So it's just this massive instrument, and they have to come up with about 30,000 variables that they're pulling out of this thing, and they have to figure out, okay, these 30,000 variables, let's pull out all the junk that we really don't care about, right? When traffic starts, when the garbage truck goes by. And let's just try to figure out if we can just come up with the one thing, which is the gravitational wave, which is we're trying to find. And in fact, they did find it last year, and the guys won the Nobel Prize for actually finding the gravitational wave. We did this project 4 years ago, before they found it, and they're still using this thing. And what I was trying to do is we have these 30,000 variables. How are we going to look at them? How are we possibly going to understand this 30,000 variables and figure out which ones are interesting and which ones are not? So the idea is, okay, how about we start grouping them up? Say, okay, these are all the variables that have to do with mirrors. These are all the variables that have to do with just regular human movement that we know about. These are all the ones that have to do with temperature. These are all that have to do with all sorts of different categories. So that's the first thing. So let's create these categories, then let's kind of average them out, then let's figure out these correlations. When temperature goes up, does the vibration of mirrors go up? Yes, there is a correlation, so we probably can start dismissing those variables. So they created this plot that's basically, we call it the LIGO plot, that just keeps on recording the data, because this is a live instrument that's constantly running. And basically, it color codes each of these groupings, and depending which one is showing most activity, it puts it towards the outer part of the circle, right? So let's say that this bright green are the mirrors. That means at this time, which was probably 20 seconds before right now, the mirrors were acting up a little bit right here, a little less right here, and probably acting quite a bit, towards the top, the mirrors were probably really vibrating or something. That was happening. So let me show you a video of this. And I'll put all these links later on in our Dropbox. I'll talk about the Dropbox a little bit too. And by the way, Luna Lee, she was also a graphic designer here from Art Center. So you see the categories of the subsystem up there, and the color-coded versus the little blocks right here. And you can see kind of this instrument just going around and just clustering the data and putting it, the most interesting towards the outside. But the whole point is that this is a live instrument, right? You don't know when these things are going to happen. So there's always somebody kind of monitoring, but they're not like staring into it, every second. So they kind of look around and go back, and then eventually they look back at this. So the whole idea of having this thing actually be interactive was key to it. So again, this is where interaction comes in. It's not just representing the data, but actually the ability to go in there and kind of start saying, okay, how is the user needs to interact with this data? So again, Luna and Stephen Bader from UW actually did the whole contextual inquiry. They looked over the shoulders of all the researchers. They see how they do their work. They said, okay, this is how you usually do. You sit around, you get your coffee, and you kind of stare at the screens and you wait for something. They usually had a humming sound going on for one of the instruments. So this whole ability to actually sit there and listen and eventually say, oh, there's something we need to look at. And they would go back and they'd say, okay, let's scroll back and let's see. And if this is interesting enough, then what's the actionable item? What happens when you find something interesting? So again, they figured out that the first thing they do is they would highlight it. They would select, okay, this is interesting, and then they would pass it on to their colleagues to actually analyze the data and figure out what's actually interesting. So this is kind of the, like I said a little earlier, there's a scientific side to data visualization. But this could be stock markets, this could be all sorts of different data. And the way to represent it, the way we interact, that's what we care about. And more importantly, is how do we make the interesting things be apparent and be obvious to the user. And sometimes, again, if this whole thing is a lot of noise and it's not interesting, then that's true as well, right? If there's nothing interesting in there to actually be looking at, then it's okay to ignore it. Now let me give you a separate example. So this is actually one of the projects that came out of class, I think 3 years ago. And this is Sean and Damien and Pei. I don't know if you know any of them. I think most of them have graduated by now. But this is actually a visualization of crime in the Los Angeles area. Okay, so what we're looking at here is the data by districts. Now the look of this, there's some patches missing here of data. So the reason is because the only data they could get is for actually Los Angeles County. Some of the other counties would not release the data, especially not in the same format. But then the idea was, okay, how do we represent the data so at a glance we can actually understand what the crime is and what we're trying to look at. So then it goes down, okay, but who actually cares about this? And the answer is, well, lots of people care about it, from the mayor to somebody just who likes monitoring crime to somebody just that's trying to move into the Los Angeles area. So that's what they did. They came up with their personas, which you guys are very familiar with. One of the personas that they said it was a student that was trying to move into USC. So they actually punch in USC into the interface. And then down here, we have this kind of like clock-like interface. So this is showing the average of crime across the different hours of the day. Right? So you expect, most crime actually happens in the evening, and sure enough, you do see it getting much fatter out here, right? So if this is crime being measured from here to here, then you do see kind of this larger thing. This highlight right here is usually leading the mouse over. So you see how their mouse over in assaults right there? So I think that's this little highlight right here. This amount of assaults for this. I think they actually did it by calls, not reports. So actually, actually playing with the data and understanding the data and importing the data is actually a big problem too with data visualization. It's something we're going to tackle, and unfortunately something we're going to have to talk and do in class as well. So here, you go to just highlighting a particular section. You change, okay, you say you don't want to see it by hour, but you actually change it to by month. So now the same thing comes to January, February, March, April, May. Now, why would we show it a clock? Why would we think we show this in a clock? In a circle kind of format. Looking at months now. Any guesses?
Is it because you can condense the data into a smaller area?
Right. So it's actually it's very appealing, right? It's compact. People understand it. Why other reason you want to set up in a circle?
Because
It repeats itself, right? So if you're actually showing multiple years, and so there's always a continuity between December and January, right? They're right next to each other. The weather is the same. There's usually something very similar. New Year's Eve happens right here. Christmas happens right here. So there's human activity that happens that has a continuity to it. So putting it in some kind of circular fashion that the beginning and the end are touching each other, it makes sense, right? Now, it makes sense, like I said, so that if it makes sense for if you're averaging multiple years, does it make sense for just 1 year? Maybe not, right? Maybe for just 1 year, then now we're putting, in this case, we're looking at 2014, right? We're putting January 2014 right next to December 2014, right? So we're putting things that happen, basically a year apart, right next to each other visually. So this kind of understanding, this kind of nuance is the kind of thing that we need to explore here. And especially how does this actually relate to the interaction and what the user is trying to understand and look at. This is a project that actually we did in this class, and I'll talk about the projects that we're going to do in this class a little later on. But again, this was 3 students a couple of years ago. Here's another project that was actually done by Chris something. I think he, I remember that name. So this is actually a sampling of albums, right? So it only goes to 2004, so it'd be much different nowadays. But it's basically songs on the top, and the sample, the albums that are being sampled at the bottom. So right away, at least for this picture right now, what do you see mostly on the top? What kind of music do you see on the top? Jazz, right? So right now, this is saying there's a lot of jazz albums sampling things from the bottom, and this is funk, soul, R&B, rock, pop, and other. So this particular picture is probably not doing the right thing, but that's what we have to try to drive at is once we start staring at it, how much information we get out of it, and how true does it seem, right? So for instance, right now this is jazz sampling, which I would not expect jazz to be the thing that's sampling most music, so I'm guessing the colors get messed up. So let me, so this is a project done by, I'll figure it right now, Jesse Chris. Yes, so Jesse Chris, quite a while ago, he went to JPL, I don't know what he's at now. Seriously? No. So this is actually done in processing. And processing is pretty wonderful that way, that it's easy to kind of start some interactive visualizations and add interaction to it. So we're going to talk a little bit about processing later on today. We're quite open to what kind of things you want to program in, but this is the way it is. So yeah, I think the color is off. I think this is a magenta. That's not the blue that's here. So these are I think pretty much hip hop albums. So if you start moving your mouse around, you start seeing different songs. So Naughty by Nature. Who's ever heard of Naughty by Nature? Yes. So this is mid-90s. So let's go on something a little more familiar. Hey, Snoop Dogg. Okay. So if I click on that, then it actually says, okay, that one album is sampling things by the Montclairs and by the Moments. So it's highlighting that, and it's actually showing other people that are also sampling some of the same albums. So here are the 2 albums that are getting sampled, and here the album that's sampling them on the left. It's just so now just out of intuition, why do you think they have a different height to them, or they have a different position in Y to them?
Their popularity.
It could be their popularity. What else could it be? The what?
Time of the year.
The time of the year? Oh, that's a good one. Yeah, it could be the time of the year.
The song length.
Song length. If we're talking albums, so maybe the album or the number of tracks, yeah. So again, so there's no right answer here, right? We can start guessing as what our audience would understand, but labels would help, some kind of sampling, or just the whole idea of playing, right? We'll let the user play with it and see what happens. So let's look at something on the top. It says one sample, and it says Beastie Boys. And then what happens as we scroll down? it's number of samples, right? So it's saying for each album, how many sound number samples went up. So it looks like Jesse actually positioned the album from top down, going downwards, depending on the number of samplings. So how does that help us? What's one information that we can probably figure out from looking at this graph right here? With respect to the height. Just anything. Tell me what to do. Where to push the button.
Look at that like little dot floating in the middle.
This guy right here? Oh, this guy?
Yeah. Is that on the bottom graph or is that on the top graph?
So because of the colors, we're actually parked on the bottom. But you're right on the money, right? So one of the things is, just by the position, we say, okay, there's something interesting about this guy. This little guy's a bit of an outlier. And if we see, this guy was actually sampled 139 times. Let's go back to it. So this James Brown album got sampled 139 times. So what's the equivalent up here? Right? It could be this guy right here. So this is the one, the lowest hanging. And sure enough, so that's 64 samples, right? So because of the position, we have decided that number of sampling is something interesting. So just by doing that, then by clicking on that, we can actually figure out that, okay, this Public Enemy album actually samples 64 different albums, most going everywhere from 65 to 85. So that was a conscious decision by the designer. It could have been length of album. So it could have been, which out of these people that are sampling, who has the longest album. It could have been time of the year, just a way to create a calendar. Then it would say, okay, apparently when you release the album in the year is somehow important to the idea of sampling. Or what Chris decided to do, Jesse. What Jesse decided to do was actually to kind of highlight the sampling count as something that the user might want to do. So the idea of a user is actually quite a bit important in data visualization too. There's always a bit of a friction when we talk about data visualization. Say, okay, come up with 3 users. And the reason we come up with 3 users is because it helps us make these decisions. Say, who's interested in this? Where it's some kid that goes to billboardmagazine.com and wants to understand this, or I was trying to find a kid for a magazine. And what does a person care about? Well, that kid probably doesn't know much about different eras, so just exploring the timeline is a good beginning. Then just looking for the person that samples the most is probably exciting and something fun to see. And then once you know that this James Brown album was the one most sampled, then there's a good chance you say, oh, let me figure out why is this so interesting. So let me listen to the album. And then when you start listening to the album, it's like, I've heard that, and I've heard that, and I've heard that piece, because it just sparks something in you. So this whole idea of bringing up this, that's interesting, and then kind of giving you, kind of building up interest, that is really exciting to do in data visualization. That's where we're getting at. And notice that all of that has the basis of the truth, right? We're not exaggerating, we're not hiding it, we're just letting the data speak for itself. Now sometimes, if everybody started sampling about the same, then the graph, the thing would be just pretty blocky at the bottom. There wouldn't be these things popping out. But for this time range, at least, there is that nice shape to it, which makes it interesting. But again, sometimes it could be just boring and flat, and that's perfectly good.
So is this data like something that he had to just like individually enter in?
So my guess is that he probably just got it from somewhere like Billboard or Spin. Somebody just publishes the data out there, and actually going there and finding your own data is going to be something that we're actually going to be doing today, later on in an exercise. So yes, if you're in this case you have 400 records, so entering it manually would be a pain. If you have a project that's big enough and people like in the city actually care about that, so they actually make an effort to collect the data and publish it and put it out there. So yes, that could be part of a project, not something that we'll do in this class. Okay. So far we've seen a scientific one about something abstract. We've shown something actually done in this class. We did something which is about music and history sampling, so that's always a fun one. Here's a different one. This is actually the NASA Exoplanet Archive, or the Kepler Archive. So these are the people that are actually using telescopes to actually look for planets. And the way they look for planets is actually quite interesting. They just look for when the stars kind of dim. Because they can't see planets from back here, right? They don't emit their own light. So all you can do is you can look at a star, and if that star all of a sudden goes dark, that means that something just flew in front of it. So they look for these kind of changes in luminosity in the light to actually try to figure out what just happened there. And they can only detect so many planets. It's very difficult, and somehow they can start figuring out what size, relative size the planet is, the possible composition of the planet, and the temperature. It's probably light diffraction or something complicated. What it comes down to is we just have a bunch of records of different planets out there that we know about, and some attributes about them that we can talk about. So Jared Thorpe, which we'll hear about some more later on, he's a professor at NYU, and he loves processing, and he did this example of the Kepler of the Kepler database, visualizing it in processing as well. Yeah, and I'll post his data and his code as well later on the Dropbox folder. So let me show you it actually running live. So just show you, this is the Kepler one. This is history sampling one. So that's something that I find pretty impressive. It's, this code is basically 8 years old, 19, yes, 8 years old, and it's still running. So processing has this staying power that is actually pretty crazy good. So I love that about processing. Okay. So what are we looking at? So we're looking at this plot, and it has these little things rotating around it, and it has a couple of other things kind of just highlighted in there. So what do you guys think we're looking at? What's your guess? Close. Remember what's the database? It's planets. Okay, so that's the first guess. We're looking somehow at planets. Now, why are they spinning? Is there any planets that we can recognize? There's 3 planets that we can recognize.
All are orbiting. We see Earth, Mercury, Mars.
Yes, right? So there's 3 planets we can recognize because they got tagged. Right? So Jared said, okay, we have this bundle of planets. So let me just show you the 3 ones that you will recognize, that you know exactly what we're talking about. So we're talking about Mercury, Earth, and Mars, right? So okay, so what's what's Earth, Mercury, and Mars doing? They're orbiting, right? So what do you think the position means? Let's talk about position. What do you think the position means? Right, so there's a distance from here to the center, right? So the most obvious thing would be like, maybe that's the distance from the planet to the, in this case, distance from, what do you think the distance from Mercury to what, and Earth to what? To the sun, right? So all these things our planets are rotating around the sun, and we know that distance, so we can plot that distance. So what about this other little random dots? What do you think that distance means?
I'm not sure what's the dots are.
Okay, so that's a question. What's the dots? Yeah. Okay, so let's start. So let's go back again. So this is a database of planets that astrophysicists have been able to detect in other galaxies. So just a bunch of planets. So right now we're talking about maybe 4,000 planets. So these are 4,000 planets that researchers have been able to detect. And nobody knows exactly what they are or what exactly they are, but we're trying to understand what those planets are. So what they decided to do is like, okay, of this database of 10,000 planets, let's put it in context of things that we do understand. We understand what Earth, Mars, and Mercury are, right?